Welcome back, everybody. This is going to be the final of two parts in my lecture series on graphing quadratic equations. If you haven't seen the first part, please go and watch it now. In this video, we're going to learn how to sketch the graph without the quadratic equation being in vertex form. Let's get started. One powerful tool that we're going to use to be able to sketch these graphs is by finding the minimum or maximum of a quadratic. There are a couple of ways that you can find this information. The easiest way, though, to derive this formula here is by using calculus, which obviously is not a prerequisite for this class. However, you can also find this information for completing the square, and I'll include a write-up on how to do that in Blackboard. So if f of x is equal to ax squared plus bx plus c, if a is a positive number, then f has a minimum at x equals negative b over 2a. And we can think about it having a minimum because remember, a being positive means it opens upward, so it's going to have a minimum. But if it's negative, it opens downward, which means it's going to have a maximum. Let's use this information to find a minimum or maximum of f of x equals 2 times x plus 2 squared minus 1. Notice this is written in vertex form, not in, we call this standard form. So the first step here would be to write it in standard form so that I know what my b value is. Let's do it. All I need to do is fully simplify the right-hand side. I get 2 times, remember, x plus 2 squared is not x squared plus 2 squared. It's x plus 2 times itself minus 1. This is going to be 2 times, filling it out, I get x squared plus 2x plus 2x plus 4 minus 1. That's 2 times x squared plus 4x plus 4 minus 1. Distributing that 2, and I need a little bit more room here. Distributing that 2, I get 2x squared plus 8x plus 8 minus 1. Combining like terms, 2x squared plus 8x plus 7. So this is, again, standard form. Standard form. And now I know my b value. Remember, a being positive means it's a minimum at x equals negative b, which is 8, over 2 times a, which is 2. That's going to be negative 8 over 4, or negative 2. Now I've got one for you to try. Can you find a min or max for this quadratic equation? Go ahead and pause the video here and press play when you're ready. I found that this attains a maximum, since a is negative, at negative 1 over 3. Here's a challenge problem for you. A farmer plans to enclose a rectangular plot of land along a river using 600 feet of fence. What is the maximum area that they can enclose? You may be thinking at first glance, what the heck does this have to do with what we've been learning? But go ahead and give it a shot and maybe you'll see the relationship here. If you need a hint, let the video play a little longer. Ready for the hint? We've got a river here, and the farmer intends to block in a rectangular plot of land using some fencing. So he's got to build 2 fences perpendicular to the river and 1 fence parallel to the river here, right? So I'm calling this W for width and L for length. See if you can create a formula to represent the area. If you need another hint, let the video play a little longer. Ready for another hint? I know that the area of this plot is going to be the width times the length, because that's the area of a rectangle. and I am trying to maximize the area. I'm trying to maximize the area. The problem is that I don't know how to maximize this area because it has two variables, not just one. But luckily, we have some extra information that's going to help us get rid of that problem. We haven't used the fact that the farmer only has 600 feet of fencing. So, between the two widths he has to build and the length he has to build, he only has 600 feet of fencing. Obviously, for maximum area, he wants to use all 600 feet. So, the 2W plus L should add up to 600. I can then solve this equation for one of my variables. All I've done here is subtracted the 2W to the other side, and I find that L is equal to 600 minus 2W. Using this expression for L, I can rewrite the area in terms of L only, right? So, in terms of W only. So this is W times L, which we just found out is 600 minus 2W. Distributing that W, I find that A of W is 600W minus 2W squared. So you can see that the area of this plot is actually modeled by a quadratic equation. Go ahead and pause the video here to see if you can finish finding the maximum. I found that the maximum area was 45,000 cubic feet. The way that I found that, of course, being, we have a formula for when the maximum of a quadratic equation occurs. And that maximum occurs at 150 feet for W. But remember, the problem asked to find the maximum area, not the maximum width of the plot. Using this information, I know that when W is 150, L, using my formula I've got up here, has to be 300. So the area would be 150 times 300, or 45,000 cubic feet. One last problem for us to try. All of this information put together, let's sketch the graph of f of x equals negative 4x squared plus 16x minus 13. Now, we could find the, in this case, maximum, since a is a negative number, and then plot a few other points. However, and let's go through and do that. So, I know this attains a maximum at x equals negative b over 2a, or that's going to be at negative 16 over negative 8, which is going to be positive 2. So this attains a max at positive 2. I'll make this a little bit bigger. So, my maximum occurs here, but I don't know what the y value is. Let's find it. So, f of 2 is negative 4 times 2 squared plus 16 times 2 minus 13. That's going to be negative 4 times 4 plus 32 minus 13. Negative 16 plus 32 minus 13. 16 minus 13, or 3. So I know 2 comma 3 is where this attains, oh, and let me use a color here, maximum value. But here's an important note. The max or min of a parabola is the vertex. So I know that this point is the vertex, which tells me I also know its axis of symmetry now. So I can infer that the axis of symmetry, happens at x equals 2. And I've done a horrible job of drawing it there. All I need are a couple of other points. I can try f of 0. That's usually an easier one to grab. I'm just left over with negative 13. The rest of my points cancel out. So 0, comma... Ooh, never mind. That's pretty far down there. Negative 13. Here's what we'll do. Give me just a minute to fix this. Okay, much better. I went ahead and changed the y-axis to be in terms of 3s instead of counting by 1s. I also know that when I plug in 1, I get negative 1, so that gives me the point 1 comma negative 1, and now I can use my axis of symmetry to flip those guys around. And now I have enough information to sketch the graph, albeit poorly because I'm doing it. In this video, we saw how to sketch the graph of a general quadratic equation, and we also looked at an application problem of why finding mins and maxes is important. That's going to wrap it up for this lecture series. I'll catch y'all on the next one.